Hey guys, this is Afif, and in this video, I'll be doing a video presentation on physics, which is topic atomic physics. Me and my group, which is Aina and Izzy, we're doing this topic, and I will take the first subtopic, Izzy will take second, and Aina will take third. So my topic will be atomic structure. So let's go. Hi guys, Afif here. Now I'm going to explain about subtopic atomic structure. Under this subtopic is divided into two parts, which is firstly the early model of the atoms, and secondly Bohr's theory of hydrogen atoms. So let's get started. The model of the atom back in the days of Newton was tiny, hard, and indestructible sphere. J.J. Thomson suggested a model where atom has a volume of positive charge with electrons embedded throughout volume. In the experiment, a beam of positively charged alpha particle was projected against a thin metal foil. Most of the alpha particles passed through it as if it were an empty space. A few scattered through large angles, and some even travels backward. We can explain this result by assuming that the positively charged in the atom was concentrated in a region called nucleus. The reverse model of atom gave way to that of Niels Bohr, which is being the characteristic of radiation emitted from atoms. Bohr's theory, in turn, was submitted under quantum mechanics. Both later theories was based on studies of atomic spectra and special pattern in wavelength of emitted light that is different and unique for every element. Now, let's continue with the Bohr's theory of hydrogen atoms. At the beginning of the 20th century, it wasn't understood why atoms of a given element emitted and absorbed only certain wavelengths. In 1913, Bohr provided an explanation of the spectra of hydrogen. His model of the hydrogen atoms included the following basic assumptions. The electron moves in circular orbits about the proton under the influence of the Coulomb force of attraction. The Coulomb force produces the electron's centripetal acceleration. Only certain electron orbits are stable and allowed. Radiation is emitted by the hydrogen atom from a more energetic initial state when the electron jumps to a less energetic state. The frequency of radiation emitted in the jump is related to the change in the atom's energy. Like stated here, the circumference of an electron's orbit must contain an integral number of de Broglie wavelength. We can write the preceding equation as, because the de Broglie wavelength of an atom is given by this formula, with these four assumptions, we can calculate the allowed energies and emission wavelength of the hydrogen atom, in which the electron travels in a circular orbit of radius with an orbital speed. The radical potential energy of the atom is given by, assuming the nucleus is at rest, the total energy E of the atom is the sum of kinetic energy and potential energy. By Newton's second law, the electric force of attraction on the electron must equal to mass of electrons multiplied by centripetal acceleration of the electron. So, multiply both sides of this equation by R over 2 to get an expression for the kinetic energy. Combining this result with the equation of total energy gives an expression for the energy of the atom, where the negative value of the energy indicates that the electron is bound to the proton. An expression for R can be obtained by solving this equation and equating the results. This equation is based on the assumptions that the electrons can exist only in certain allowed orbits determined by the integer n. Then, the orbit with the smallest radius, called the Bohr radius, A0, corresponds to the n equals 1 and has the value of 0.0529 nanometer. The general expression for radius of any orbit in the hydrogen atom is obtained by substituting A0 into Rn, which equals to n squared times 0.0529 nanometer. Next, Rn can then be substituted into the equation of energy to give the following expression for the energies of the quantum state. If we substitute numerical values into this equation, we can obtain this formula. That's all from me. Now it's Izzy's turn.
Hi, my name is Izzy. This is me, the one with the white shirt. Yes, better. And my life is kinda crazy. Wait, that's the wrong intro. Guys, cue in the backup intro, please. Okay, so this is basically a simplified version of an atom, and they kind of boring because most of the time all we do is just sitting there. Yeah. Now the real star of the show is the electrons. They do a lot of kind of stuff like moving, binding with other atoms, and uh, moving. Okay, so the dashed line that you can see is called the energy level that the electron can have while in the atom, and it's very specific. We often represent this energy level with a diagram. So let's say that our atom can have 3 different energy levels, 4 eV, 6 eV, and 7 eV. So basically in the diagram, the Y represent the energy level and the X-axis represent basically nothing. They're just there because mathematics. Note that our hypothetical electrons here can only exist in energy level of 0, 4, 6, and 7 and cannot exist in the middle between any of those. That's why it's very specific. So let's start off by putting our electron at the 0 eV, the lowest, or what we call the ground state. Other levels that are higher than the ground state are called excited state. So how to get them jump from this ground state? Well, we all know how to give electron energy, right? We just shoot light to them. So if a photon of the right energy can hit an electron, it will absorb all the energy and jump to another energy level. Note that from ground state, the electron can only absorb specific range of energy. It can only exist in the specific energy level of 0, 4, 6, and 7. Other than the energy that can help them jump to this energy level will not be absorbed, and it will just pass through the electron, and vice versa for energy releasing. So if we were to shine lights that consist of all possible wavelengths through a gas that composed of our pretended atom, some of the wavelengths that carry the specific amount of energy that needed will get absorbed and scattered away. So this will result of not all of the light will get through, and this missing light wave will manifest itself as the dark lines on the projected light. So the product of this projected light is the thing that we call the spectrum something, the absorption spectrum. Now we're gonna talk about the emission spectrum. When atom falls down its energy level, it emits energy that can exist as photons. So instead of seeing the light spectrum with some of the wavelength missing, you will only see a handful of lines that correspond to the energy that are released by our hypothetical electrons.
Hi, so this is my turn. Thank you, Afif and Easy. So now I will talk about Xray and laser. So what is Xray? Xray technology has allowed us to see what's inside the human body. So usually doctors use it to see through the human tissue to examine any broken bones, cavities, or electrons are emitted from a heated filament and accelerated through a large voltage. When they strike the target, the ground state electrons are knocked out of the orbit. So the higher orbital electrons then jump to occupy the vacant space, so that X-rays are emitted. I'm sure that it is not really totally explained. So watch this. X-ray machine. There's an electrode pair, anode and cathode, inside of the vacuum tube made of glass. The cathode is usually a heated filament. As the cathode is heated up, electrons spark out from the filament and find their way to the anode. The voltage difference is very high, which allows the electron to travel through the air with a high velocity. As these electrons travel through the tube that such a high phase and hit the tungsten atom of the anode, it knocks loose electrons in the lower orbital of the atom. As the electron falls from higher orbital to lower energy level, the extra energy is released as a photon. Since this drop is large, it releases high energy photon or an X-ray. This is how normal X-ray are produced. Whoa, that is X-ray. So let's move to laser. So laser actually is an acronym for light application by stimulated emission of radiation. The laser produces a very narrow beam of light that is very useful in many technologies and instruments. The active laser medium or gain medium is the source of optical gain within a laser. The tube contains the atoms that are the active medium. There is a mirror at each end of the tube. The pedal and mirrors provide the feedback of the stimulating wave. Xenon flash tubes have been used to produce an intense flash of white light. What actually happens in the tube? Electron is excited from a lower to a higher level. So when an electron decays to a lower energy, it emits a photon. Light bounces back and forth between the mirrors, passing through the gain medium and being amplified each time. Some of light escapes through the mirrors that are partially transparent. So, this is the laser light. So, that's all from us. Thank you guys.
Okay guys, thank you for watching. Like and subscribe, okay? Bye!